Right, so in this video we're still going to be looking at solving one-step equations through modeling. We just have a different type of equation we're going to be working with here. What does stay the same is the tiles I'm going to use. So remember in the last video we talked about a green rectangle would represent positive x, and a blank rectangle or a white rectangle would represent negative x, as well as if we have the little squares, the one that's colored in red is positive 1, and the one that's colored in white is negative 1. So same shape, but if it's got color to it, it's positive, and if it is colored in white, then it is negative. So with these ones, I'm going to be looking at solving this. 3x is equal to 12. So I've got a coefficient now of 3. That really means 3 times x is going to equal 12. So what I'm going to do, I've got a really easy, smart way of laying this out. So whenever I have more than one x going on, so now that I have 3 of them, what I'm going to do is I'm going to draw my 3 x's, and I'm going to put them horizontally like this in 3 neat rows. And just putting them in rows makes it really, really simple for us to lay this out easily. So I've got my 3 x's on the left-hand side, and on the right-hand side, all I'm going to do is I'm going to take my 12 ones, and I'm just going to organize them into 3 equal rows, right? Because I've got 3 x's, so I'm just going to organize them into 3 equal rows. So I've got 1, 2, 3, and then 4, 5, 6, and 7, 8, 9, and 10, 11, and 12. So I just drew out my 12 ones to represent positive 12. And this type of model is really easy because all I'm doing is saying, well, how many ones match up with each of my x's, right? If I have 3 x's, it's can I split my stuff on the other side into 3 equal groups? So that's really all I'm doing. I've got one group of an x and 4 ones, and another group that's exactly the same size that contains x and 4 ones, and one more group that's the exact same size that contains x and 4 ones. So in total, my answer is, I'm just looking at a single group. My single group has x and, on the other side, 4 ones. Every group has the same amount of stuff in it, and what's inside each group is my answer. So that model is actually really fast and easy, and I can simply say x is equal to 4. Okay? So let's try another one. Let's say I've got negative 2x is equal to 6. So this one's going to look a little bit different because now my x's, instead of being positive, are negative. But I'm still going to take my negative 1x, and then I need a second one because I need to have 2 negative x's. So I'm going to draw out my 2 negative x's. I'm still going to put them into 2 rows. And then on the other side, I'm going to organize my 6 ones into 2 equal groups. So 1, 2, 3, and then 4, 5, 6. So in total, I've got my 6 ones laid out into 2 equal groupings where each group is going to have 3 ones in it. So I go like this. I've got a group that's got a negative x and 3 ones, and another group with negative x and 3 ones. And so I'm going to draw that out. That's part of my answer, is I would say, well, negative x is equal to 3 positive ones. But this is kind of a problem. I don't want an answer that has negative x. I never want an answer that's going to tell me what negative x is. I don't want that. Okay? So remember, with our 2 tiles, negative x and positive x, they're the same size, and when it's colored in, it's positive. Now, if you had them sitting on your desk at school, what the teacher would show you is you just flip it over, right? So now that I've got this negative x, I don't want a negative x, I want it to be positive x. So you know what I'm going to do? I'm just going to flip it over. So I'm going to flip it upside down, and now it's colored in green. And remember, whatever I do to one side, I have to do the same thing to the other. If I flip this from white to green, I have to flip all of these from red to white. And I just make sure that I do the exact same thing on both sides. So I just flip my tiles to their opposite colors. Okay? everything flips to its opposite color. And now, instead of saying negative x is positive 3, I know that my answer is positive x, and it equals negative 3. So what I had before was negative x is equal to positive 3, and I really just took the opposite sign on both sides to get positive x is equal to negative 3. Okay? A little bit easier when you have the tiles in your hand and at your desk to solve. Okay? Let's do another one where we might need to do some flipping. Okay? So negative 5x, so I'm going to start out by drawing my 5 negative rectangles. Okay? And again, I put them into 5 neat rows, and that way I'm allowed to now on the other side take my negative 10 and put them into 5 equal groups, or 5 equal rows, and I'm looking at what I end up getting in each and every row. Okay, so when I color these guys in, you can see I've got 5 rows. Each row has one negative x as well as 2 negative 1s, right? So each contains a negative x and 2 negative 1s. Okay, so I'm going to now state what each group holds. Each group holds that negative x and my 2 negative 1s. Okay, and then I need to not have my answer as negative x. I need it to be positive x, so remember I'm going to flip my color from white to green, which means these guys also flip their color because I have to do the same thing on both sides, and they flip from white to red. And my final answer here now says x is equal to positive 2. Okay? One more. And then, oh, it's the same one. I'm not doing one more then. If it's the same one, you've already seen it. That would be a waste of everybody's time. Okay? So that makes sense if I'm looking at my equation because it says negative 5 times x equals positive 10. I knew my answer for x had to be positive. Because if I'm going to go negative 5 times something, and I get negative 10, I knew it had to be negative 5 times positive something, because negative times positive is negative. So my missing number, my x, my variable, my missing value, had to be something positive. And 5 times 2 is 10. Okay? All right, there we go. That's modeling one-step equations when we have a coefficient for x.